Good morning, students. I welcome you all for the another session of analysis of determinate structures. So we already studied and we know how to calculate the reactions and normal thrust and radial shear at various points on the arch. So let us take one more problem on and try to solve this problem and how to draw the bending moment diagram. Once again, we're going to see. The problem is like this: a three-hinged parabolic arch of span 24 meter, okay, rise 6 meter with hinges at abutments and at crown point. Arch is subjected to a point load of 50 kilonewton and 150 kilonewton at a distance of 8 meter and 20 meter from the left support. So there are two point loads, that is 50 kilonewton and 150 kilonewton at a distance of 8 meter and 20 meter from the left support. So for this, they were asked to find out the reaction at supports, okay, reaction at the supports, bending moment at load points, that is bending moment at D and bending moment at E. So below the load points you have to find out the bending moment and also have to draw the bending moment diagram. So that next third one they asked normal thrust and radial shear at a distance of 6 meter from left support. So at a distance of 6 meter means before this load. So at a distance of 6 meter from A, so you have to find out normal thrust and radial shear. Okay, so this is the problem. So as per the problem, this is the diagram. Okay, so hinges at A, C and B and 2 point loads 50 kilonewton and 150 kilonewton. So this 50 kilonewton is at a distance of 8 meter from support A and this 150 kilonewton is at a distance of 20 meter from support A only. So one is 50, that is 8 meter and another will be 20 meter from the left support E. Now as usual, first we are going to find out the reactions. So A is also a hinged support and B is also hinged support and these are the reactions, that is vertical reaction VA, horizontal reaction HA. Similarly, vertical reaction at B, VB and horizontal reaction at B, that is HB. Okay, for this first step is to find out these reactions. First we'll find out the vertical reactions, then we'll find out the horizontal reactions. Okay, so let us find out the vertical reaction, that is VA and VB. Now as you know, consider the total arch and in that first equation we're going to use summation MA. Take moment of all the forces about A. Okay, so now there are forces. See here. So this is the force. Okay, we are taking moment of all these forces. The moment of these two will be 0, right? We have to, this is also 0. Now we have to take moment of 50, moment of 150 and moment of this VB. And already you know that clockwise moments we're going to consider positive and anti-clockwise we're going to consider negative. So first 50 into 8, that is a point load 50 kilonewton into distance between 50 kilonewton and support A is 8 meter. Then second load, point load is 150 kilonewton, that is 150 into 20. Okay, then minus anti-clockwise VB is minus VB into total span 24. So this is summation MA, this is equal to 0. So if you calculate VB, will going to get 141.66 kilonewton. Okay, so one vertical reaction we have got at B. Now similarly another equation we are going to use, that is summation Fy is equal to 0. The sign convention, vertical force positive, downward force negative, that is upward force positive, downward force negative. So there are how many vertical forces, that is VA 50 kilonewton, 150 kilonewton and VB. So as per the sign convention, it is plus VA minus 50 minus 150 plus VB. So this is summation Fy, this is equal to 0 and we're going to get VA because VB is already calculated. You can substitute here. So VA is going to get 58.33 kilonewton. So this is finding out the vertical reaction. So similarly, we're going to find out the horizontal reactions, that is at A and at B, that is HA and HB. So HA and HB equal to same here. So any one you can find out. Okay, so while finding out the reactions, horizontal reactions, only you can consider the half arch, that is either AC or either CB. So let us consider the half portion of the arch, that is CB. So this is a C, this is point B or support B. So there are two reactions, that is VB and HB, and in this 150 kilonewton force will be acting. Okay, so from center this is, so half span is 12 meter, and from center point C this 150 kilonewton load is 8 meter, so remaining is 4 meter. So this is the diagram, that is half portion of the arch we are going to consider. Now as usual we are going to take moment at C is equal to 0, because even this C is hinged support, so the moment at C is equal to 0. So let us take a moment of all the forces about C. Okay, same sign convention, positive, that is clockwise it is positive, anti-clockwise moment it is negative. So now see here, so first I'll take this VB, so this is anti-clockwise with reference to C, so VB into 12 meter, so VB into 12 meter, then this will be clockwise, plus HB into 6 meter. See, this is the rise of this arch is 6 meter, then this 150 kilonewton force, this is with reference to C, this is also clockwise, 150 into, okay, this is 8 meter, 150 into 8. So this is a summation MC, this is equal to 0. Okay, so now from this we can calculate reaction, that is horizontal reaction, HB is equal to 83.32 kilonewton. As we know already that HB is equal to HA, so both are same, so therefore HA is equal to HB is equal to, you can indicate this as a H, that is horizontal thrust. H is equal to 83.32 kilonewton. So this is the first step what they have asked, reactions at the supports. So we have found out VA, VB, then HA, HB, that is H is equal to 83.32 kilonewton. Now let us move on to the next thing what they have asked, bending moment at load points, that is the loads will be at this point, that is D. I will indicate this point as D and this point as E. Now we have to find out what is the bending moment here now. What is the bending moment at D and what is the bending moment at E? So load points, below the load points we are going to calculate the bending moment. So now the third step will be bending moment calculation below the load points. Okay, for this, now see, so before calculating the bending moment at D and E, first we are going to calculate the vertical ordinates. Okay, vertical ordinates, that is YD and YE. Okay, so we know that first you write down the parabolic equation. So at any ordinate, any vertical ordinate, Y is equal to 4hx divided by L square into L minus x. Now first calculate at D what is vertical ordinate, that is YD. So YD, okay, means at x equal to 8 meter. So D will be at a distance of 8 meter from support A. So here central rise will be 6 meter, that is small h is equal to 6, x is equal to 8 meter, and L, total span of the arch, is 24 meter. So in this YD is equal to, substitute the values, 4 into h is 6, x is 8, then 24 square into bracket 24 minus 8. So we get YD is equal to 5.33, means the vertical ordinate YD is equal to 5.33 meter. Similarly, at another load point, that is E, so we are going to find out. So E will be at a distance of 20 meter from support A. Okay, so here also h is equal to 6, but x is 20 meter now. From support A, point E is 20 meter, then L remains same, 24 meter. So substitute the values here, we will get another ordinate, that is YE is equal to 3.33 meter. Now we can calculate the bending moment at D and bending moment at E. Now first bending moment at first load point, that is at point D. Okay, so draw the arch portion, that is AD. Only you have to consider AD. So AD, so at D there is a 50 kilonewton force. Okay, and from A, point D is 8 meter. Okay, and YD just now you have calculated 5.33. So with this, VA is already calculated, H is calculated, write down these values here. Okay, now Remember, important thing is now we are calculating bending moment now, okay, not moment. Okay, so while calculating bending moment, you have to remember the sign convention. Sagging is positive and hogging is negative. Okay, so that point you have to remember. So therefore bending moment at D, so bending moment at D is equal to, okay, so 1 by 1 force you can take. First is VA. Okay, so with reference to D, so this is a, this force will going to produce, okay, sagging. So this is plus, so plus VA in plus VA, okay, into 8, plus VA into 8. Then this with, okay, minus, this will becomes minus H into YD, minus H, this is the force, and perpendicular distance between D and this H is 5.33. So 58.33 into 8 minus 83.32 into 5.33. So we get bending moment at D is equal to 22.54 kilonewton meter. So bending moment at D is equal to 22.54 kilonewton. This is positive. We have got the value as positive. So write down positive bending moment. So similarly, next another point they asked, calculate the bending moment at second point load. That is, second point load is here now. Second point load is at point E. Okay, so we're going to draw the arch section from A to E, or even you can consider only portion BE also, no problem. Even you can consider only portion BE, then calculate bending moment at E, that is also possible. Okay, so let us consider portion AE. Now from A to E, whatever the loads are there, you can consider. This is at D 50 kilonewton and at E 150 kilonewton point load, and as usual at A, so these are the horizontal reaction and vertical reaction. Okay, now we're going to take bending moment. Where we want to calculate bending moment at E. Now again sign convention is sagging is positive, hogging is negative. So bending moment at E is equal to, so take 1 by 1 force. So first I will take VA, so this is the vertical force, VA into perpendicular distance between this VA and E is 20 meter. So plus VA into 20 meter, then minus, okay, this load. So this is a force, this is a force, and what is the perpendicular distance between E and H? Okay, so that is YE. Just now you have calculated here YE. So this is minus, so minus H into YE, and similarly, okay, this 50. So this will going to create, okay, hogging. So this is minus, so minus 50. Okay, minus 50, and what is the perpendicular distance between this 50 kilonewton and E is, that is 8 plus 4 12. So VA into 20 minus H into YE, and minus 50 into this 12. Okay, so we can calculate bending moment at E is equal to plus, see, remember this also you got plus 289.14 kilonewton meter. So this is the second point they have asked, calculate the bending moment at D and calculate the bending moment at E. So bending moment at D is this and bending moment at E will be this. So now the third point what they have asked, now third as usual, normal thrust and radial shear. Okay, normal thrust and radial shear at 6 meter from left support. They have given, you have to calculate normal thrust and radial shear at 6 meter from left support. So again now see, I'll mark this point 6 meter from X, indicate this as a F, point F. So this is 6 meter and this is support A. As usual, these are the two reactions we have shown. So now again remember equation of parabola. So we know that y is equal to 4hx by L square into L minus x. Okay, so first we'll calculate the y, or even directly you can go to this now. Directly you can go this. We want to calculate theta. Okay, so when theta is not known, you cannot calculate normal thrust and radial shear. First calculate the theta. So directly you can come to this. As you know, slope or theta we can calculate it as dy by dx is equal to tan theta. Okay, slope tan theta is equal to dy by dx, or tan theta is equal to dy by dx. So therefore tan theta is equal to d by dx of y. Now you have to differentiate this y. Okay, that is 4hx by L square into L minus x. So d by dx of 4hx by L square into L minus x. So I can take this 4h by L square, 4h by L square, x into L, okay, x into L, then x into x minus x square. Okay, now differentiate this. Tan theta is equal to, this will be remains as it is, 4h by L square as it is. Then differentiation of xl is, x is 1, so L you can write L minus differentiation of x square is 2x. So differentiation of this is L minus 2x. Okay, so substitute here 4 into h. So central rise will be 6 meter divided by total span will be 24 square into bracket 24 minus 2 into x. 2 into x. What is x now? We have to calculate normal thrust and radial shear at 6 meter they have given. So x will be 6 meter. So it is 2 into 6 meter. So therefore we can get tan theta first we are going to get, then theta is equal to tan inverse we are going to get 26.56. Okay, this is a slope, or theta is equal to 26.56. So once if we get theta, okay, now let us calculate shear force at F. Okay, shear force at F. So what do you mean by shear force? Shear force is nothing but it is the summation of, okay, vertical forces, only vertical forces, okay, with sign convention. So if it is a upward force is there, it is positive. If it is downward force is there, it is negative. So shear force at F, only vertical force. How many vertical force? Only one here. So don't consider this. I am saying summation of all the vertical forces between A and F. Okay, so only one force is there. So therefore shear force at F, V is equal to VA. So plus VA. So therefore V is equal to VA, already we have calculated. This is 58.3. This is the shear force at F. So once if we get theta and once if we get shear force, now we can calculate normal thrust. So normal thrust at 6 meter from A. Okay, so normal thrust at point F. So that is N is equal to, normal thrust is indicated by N. So N is equal to H cos theta plus V sin theta. Already we know in the previous sessions. So normal thrust is equal to H cos theta plus V sin theta. So therefore H already you have calculated, substitute that, theta you can substitute. So we get normal thrust N is equal to 100.6 kilonewton. Okay, so normal thrust at 6 meter from left support, that is at F, is equal to 100.6 kilonewton. So next, similarly you can calculate radial shear. Radial shear, either it is indicated as F or it is indicated as Q. Okay, so radial shear Q is equal to, now it is H sin theta. Okay, remember H sin theta minus V cos theta. Okay, so again substitute H value and V value and theta value. We will going to get F is equal to, or Q is equal to minus 14.91 kilonewton. So these are the two values, that is a normal thrust N and radial shear Q or F at point F, that is 6 meter from the left support. This is the third, and in the second quantity they have asked draw the bending moment diagram. Now let us draw the bending moment diagram. Come to the first diagram where you have started the problem. Okay, so now here this is the bending arch, given arch. So as it is, you have to draw first arch. Okay, A, C and B. Okay, as it is, you have to draw A, C and B. Okay, so now on this we already calculated bending moment at D. So this is a point D. So bending moment at D, it is a positive. Already we have calculated, it is 22.54. So from this you can mark 22.54. Positive means above the arch, that is at D. Now similarly bending moment at E. Bending moment at E. Now this is the point E. Okay, this is point E, and here also we have got. Okay, so bending moment at E is equal to, again it is positive. Okay, 289.14 kilonewton meter. Now see, this will be more. So it is 289.14 and this will be 22.5. So this is 22 and from this it is 289.14. And you know that, so A is hinged support, means bending moment at A is 0, bending moment at B is 0 and bending moment at C is 0. So while drawing, now you have marked this point, we have marked this point. So from A to D, A to D, is there any load? Okay, no load between A to D. Okay, join this with the straight line. Join this with straight line. Now remember, since bending moment at C is 0, okay, so you have to close this. So moment at C will be 0. You join this point. Now again bending moment at E we have marked plus. Above this again arch to 89.14. Now again from C to E you can come with a straight line, and again from E to B there is no load here. Again join this point with the straight line. So this is what the bending moment diagram. So this is also positive and this portion is also positive. So this is what the bending moment diagram you will going to draw. So I hope you have understood this problem, right? Solve once again. If you any doubt, please feel free to ask me at any time. Thank you very much for attending this session. Thank you.